Okay, here's warm-up 1.1. So this first problem represents a very common algebra mistake. A lot of times when we've got a binomial that's squared like this, I'll see people write, oh, I'll just square the x and square the 4. 4 squared is 16. But that is incorrect. That's wrong, okay? Because you got to think about this as the quantity x plus 4 times itself, which means that you'd have to distribute the x, then distribute the 4, or you can FOIL. I'm going to use FOIL, so F-O-I-L stands for first, outer, inner, last. So first means I'm going to multiply the parts out front. X times x is going to be x squared. Outer is the parts on the outside. X times 4 would be 4x. Inner would be the parts on the inside. 4 times x is 4x as well. And then last, at the end of their parentheses, the 4 is 4 times 4 is 16. And then I add together all of those bits, and I've got these like terms in the middle, which I can combine into 8x. So here is my solution. So you can see if you just square both terms, you miss out on the middle term on the 8x. Okay. And next problem, we're going to factor this completely. So you always want to look for a common factor, but there's nothing that goes into all three terms. So if this is factorable, which it is, it's going to look like this. It's going to be two binomials multiplied together like this, and it has to start with x's to get the x squared. Okay. So there are a number of different ways you can do this. I'm going to use a diamond problem. So I'm going to set up a little x. I'm going to take this 7 and put it up there, and I'll take the 12 and put it down here. And this is a little puzzle. I'm trying to figure out what numbers go in the left and right slots here. So I need two numbers that add up to 7. The same two numbers are going to multiply to 12. So when you think about ways to multiply to get 12, we've got, let's see, these. We've also got the double negative versions of these, like -1 and -12, but none of the double negatives are going to add up to +7. So I'm just looking at these, and there's my winner. 3 times 4 is 12, and 3 plus 4 is 7. So the 3 and the 4 go in those slots in either order. You could reverse their order. But that tells me what goes in the back of these parentheses, a +3 and a +4. And there we go. And you could always test your answer out by foiling it back together. It should get back to x squared plus 7x plus 12. Okay. All right, this next problem, I've got a long polynomial here. I'm just going to simplify this by combining like terms. So I'm looking for x squared terms first off. Well, there's an x squared term. Here's one. And those are the only two. Okay, so those are going to combine. I've got 2 of those minus 5 of those. That means I've got -3 of those being x squareds. Okay. And then let's do the x terms next. So let's see, we've got 5x and 1x would be 6x when you add them together. All right, and then the y terms, I'll put a box around these. I'm just kind of grouping these here. 3y minus 2y would be 1y. And then last up, that's one of a kind. There's nothing to combine the 8 with. So this is now simplified. I've combined the like terms there. Okay. All right. This next problem, we also have like terms that we need to combine. So ultimately, when it says solve, I'm solving for x. I'm going to start by combining these two x terms. So I want to get them on the same side of the equation. You could either subtract 4x from both sides or 2x from both sides. I'm going to subtract 2x. Just that way my x's will stay positive. So I usually do it that way. So this is going to be 2x over here. Okay, 2x minus itself is nothing, and then so I just have the 7 left over there. I still have these like terms which I want to combine, and I want to isolate the x. So I'd rather subtract 3 from both sides than subtracting 7 because I'm trying to get the x by itself. Okay, so then 2x is going to equal 4, and the last step would be to divide by 2. So that's the opposite of multiplying by 2. And then I get x equals 2, and that is my solution. And that is the end of the warm-up, and I'll see you next time.